In this video, I'm going to teach you how to write the formula of a complex when the name is given. In a complex, we have both the simple ion or the counter ion and the coordination entity. So for the simple ion where the cation or anion behaves like free ion and carries usual charge as one radical. Now for the complex ion, charge on the complex ion is computed on the basis that it is equal to the charge on the central metal atom plus the total charge carried by the coordinated ligands. So if the charge on the complex ion is X, then X would be the sum of the oxidation state of the metal and the charges on the ligands. We come to point 3. Now a molecule of the coordination compound as a whole is neutral. So the total positive charge must be equal to the total negative charge. So the cations and anions are therefore multiplied by such constants so that the charges become equal. These constants give the number of each type of ions. As of now, you might not understand this one, but when we come to the sample problem, you will understand this one better. So let us come to sample problem number 1. Formulate the compound tetraamine aqua chlorido cobalt 3 chloride. Here you have to identify the simple ion, whether it is an anion or a cation. Obviously, here the simple ion is an anion, which is chloride. So what is the charge carried by Cl? It is minus. Then we come to the what? The coordination entity. So the coordination entity would be your cation, okay, or the complex ion. So for that, first you have to write the symbol for central metal atom. Look from the name, what is the central metal atom from here? It is cobalt. After that, write the ligands, the symbol for the ligands in alphabetical order. Write first amine. How many amine are there? Molecules? There are 4. Tetraamine, 4. And then followed by aqua, which is H2O, and then followed by chlorido, which is Cl. And then we want to know the charge on this complex cation. Let that one be X, okay? So now let us calculate that one. So how is X calculated? X is equal to the charge on the central metal atom. What is the charge on the central metal atom or the oxidation state? It is 3 plus 3 plus 4 into charge on the ligand. Charge carried by NH3 is 0. Okay? What about H2O? This one also is a neutral molecule, so the charge is 0. What about Cl? It is minus 1. So what would be your X? Your X is plus 2. Plus 3 with minus 1, we have plus 2. Okay? So we see that charge on one anion is what? It is minus 1. Yes, minus 1. And then charge on one cation, the coordination entity, it is plus 2. But the molecule is neutral. So what happened? Here we should get minus 2 in order that minus 2 gets cancelled with plus 2. So for that, if charge on one anion is minus 1, then there should be 2 Cl minus, so that minus 2 will get cancelled with this plus 2, and therefore the molecule or the compound becomes neutral. Okay? So therefore, what would be the formula? The formula for a given compound. Therefore, the formula for a given compound is what? It is cobalt, NH3, 4. Okay, there is no space. All right, here, okay. So what would be the formula for a given compound? Cobalt, NH3, 4, H2O, Cl. here we have Cl minus, okay, but there should be 2 Cl minus, so that we will get minus 2 in order that this one gets cancelled with this, right? So there should be Cl2 of this form. So hence this is the formula. Okay, so we come to sample problem 2, the same procedure. You have to formulate this compound sodium pentaziano nitrosyl sulfidoferrate 3. So here you have to identify which one is a simple ion, whether it is a cation or an anion. So clearly the simple ion here is our cation, sodium plus, okay, and the coordination entity or the complex ion, which is the anion. First we have to write the central metal atom. Look from here, it is Fe, central metal atom, and then write the ligands in alphabetical order. Pentaziano, nitrosyl means NO, okay, sulfido means S, and then X. We want to know the charge on the complex ion. For that, X is calculated as, what is the charge on this Fe, or the oxidation state? It is +3, okay, +3. And then charge on Cn is -1, charge on NO is 0. What about the charge on sulfur? It is -2. So what would be your X? Here we have +3 -2 with -5. We get -4. So what do we see? We see that charge on one cation, charge on one cation is +1, right? +1. Charge on one anion, the coordination entity is -4. So what happened? We have to get +4, right? In order that +4 gets cancelled with -4, so that the compound becomes neutral. So what would be the formula then? The formula for the compound should be of this form. So write sodium, and then the coordination entity CN5, nitrosyl sulfur, okay. So here we should write 4. Why? Because Na4 means 4Na plus, and 4Na plus means +4. This +4 will then get cancelled with -4. That is the charge carried by this complex. What complex? Anion. Okay. So this is how we calculate, this is how we formulate the compound when the name is given. That's all. Thank you.